Hello guys, welcome to the new video. In this video, we are going to prove that root 2 is an irrational number. Now, we prove by using proof by contradiction. So we assume that root 2 is rational, and after assuming that root 2 is rational, we are going to hit some contradiction or a statement that is not at all true. Then we can say that our initial assumption must be wrong. So root 2 will be irrational. So let's assume root 2 is rational. So by the knowledge of rational numbers, if root 2 is rational, then there exists integers r comma s and s not equals to 0, such that root 2 is equals to r by s, right? If root 2 is rational, then we must be able to express it in terms of r and s, where s is not equals to 0. Suppose, let's assume that r and s have some common factors, and after dividing both r comma s by their common factors, we got a by b, where a and b doesn't have any common factor. A comma b doesn't have any common factor. So for example, we there is 4 by 6. The common factor, the highest common factor of 4 and 6 is 2, and we cancel out that 2 from both numerator and denominator. We reach to some point where the numerator and denominator doesn't have any common factor. So we reduced r by s to a by b, where we cancel out the highest common factor from r by s. We reached to a by b, where a and b doesn't have any common factor. Now let's do some basic algebra. Let's square on both sides. So root 2 whole square is equals to a by b whole square. From this, we are going to get 2 is equals to a square by b square, which implies a square is equals to 2b square. So from this, we can clearly say that 2 divides a square, right? A square is equals to 2 times b square, which means 2 divides a square. Since 2 is a prime number, if p divides a square, this implies p divides a. We have proved this in the previous video. If a prime number p divides a square, then the prime number p will divide the a. So this implies 2 divides a. Okay, if 2 divides a, then we can write a as 2 times some integer c, because 2 divides a, then we can write a as some 2 times c. Now let's substitute this 2 times c back into the above equation, so which makes 2c whole square is equals to 2 into b square, which implies 2 square is 4c square is equals to 2b square. This implies b square is equals to 2c square. Now, similar to the previous logic that we have done, from this equation you can say that 2 divides b square. This implies 2 divides b. Therefore Previously, we have proved 2 divides A. Now we proved 2 divides B, which means A comma B have common factor 2. So we hit a contradiction. So the initial assumption is that root 2 is rational. From there, we reached a point A and B doesn't have any common factor, but after some point we reached to A and B have common factor. So which is true? Like at some point we are saying A and B doesn't have any common factor, but after some algebra, after some manipulations, we are saying A and B have common factor. So there is no strength in our argument, or it's not correct, right? Saying a person is male for some time and after that you're saying the person is female. It's not possible. So A and B doesn't have any common factor. After that we are saying A and B have common factor. So this is completely wrong to say. This is completely illogical and it is completely not valid in the field of mathematics to say something as true for some time and again saying something as not true. So this is a contradiction. We are contradicting ourselves. We are saying this as true, after that we are saying this as true. So we are contradicting. So which means our initial assumption must be wrong. So our initial assumption that root 2 is rational is wrong. So therefore root 2 is irrational. So this is a classic proof by contradiction based proof that we have done. I hope you really understood what is proof by contradiction. We assume something as not true and we hit a contradiction, so something must be true. Okay, I hope you really like this video. If you really like this video, please like, share and subscribe, and thanks for watching.